Right now, without feeling a thing, you are moving at 600 kilometers a second. Not around the sun, not around the galaxy. The whole Milky Way is falling in one direction, and the thing pulling us sits behind the one part of the sky we cannot see through. I'm Rook. This is Odd Signal. Start with how we know we are moving at all. Everything in the universe drifts apart as space expands. Strip that expansion out, and what is left is your own private motion. Ours was measured against the oldest light there is, the microwave glow left over from the Big Bang, filling the whole sky at almost exactly the same temperature in every direction. Almost. Because we are moving, one side of the sky looks very slightly hotter, and the opposite side very slightly colder. That tilt is a speedometer. It says the local group of galaxies, us, Andromeda, and a few dozen smaller ones, is running at roughly 600 kilometers per second relative to that ancient light. Fast enough to cross Belgium in under half a second. In the 1980s, a group of 7 astronomers set out to map where all that motion pointed. Alan Dressler, Sandra Faber, Donald Lynden-Bell, and 4 colleagues measured the private motions of hundreds of galaxies. The press called them the 7 Samurai. What they found was that we were not being tugged at random. Whole swathes of the sky were streaming the same way. Hundreds of millions of light years of galaxies moving together like water tilting in a bowl. Dressler gave the destination a name, the Great Attractor. And here is the strange part. The direction everything is falling toward lies in the constellations. Norma and Triangulum Australe, somewhere between 150 and 250 million light years away. It sits directly behind the disk of our own galaxy. Dust, gas, and crowded stars block the view. Astronomers call it the Zone of Avoidance, and for most of the 20th century it was a blank stripe across every map of the sky beyond our galaxy, a band where the universe simply went missing. The most important structure in our neighborhood, and we cannot look at it in ordinary light. So we went around the problem. Radio waves pass through dust. So does infrared. So do X-rays. Point those instruments at the blank stripe, and shapes start to appear. What is actually? There is not a monster. There is no giant black hole at the heart of the Great Attractor. No exotic object swallowing the neighborhood. There is a crowd, a concentration of galaxy clusters, with the Norma cluster, catalogued as Able 3627, sitting near the middle of it, an enormous cluster hiding behind our own galaxy's glare. Around it, walls and filaments of galaxies stretch across the region. That should have been the end of the story. A big pile of mass, pulling us in. Except when astronomers weighed the crowd, it is not enough. The mass we can find in the Great Attractor region does not account for our full 600 kilometers a second. And when the surveys reached deeper, they found something stranger. Galaxies are not stopping there. The flow carries on, past the Great Attractor toward the shapely supercluster, a far larger concentration of galaxies, several hundred million light years further out. We are not falling into the Great Attractor. We are falling through it. In 2014, a team led by Brent Tully with Helene Courtois, Yehuda Hoffman, and Daniel Pomered tried a completely different approach. Instead of asking where the mass is, they asked where things flow. Map the motions of thousands of galaxies, trace every stream back, and see which ones drain to the same place. Rivers define a watershed. Galaxy flows define a supercluster. And when they drew the edge of our own watershed, we gave it a name, Laniaka, Hawaiian, for immense heaven, roughly 500 million light years across, containing something like 100,000 galaxies, with the Great Attractor sitting at the bottom of the basin, the point everything drains toward. For the first time, we had a home address. Then came the part I find hardest to sit with, because in 2017, the same group published a result showing that about half of our motion is not a pull at all. Their maps kept showing an enormous region on the opposite side of the sky, almost empty of galaxies. And empty space can push, not literally, but the effect is identical. If everything around you is denser than the place behind you, you are accelerated away from the emptiness, just as surely as you are pulled toward the crowd. They called it the dipole repeller. Their conclusion was that our motion is driven roughly equally by two things: the pull of the shapely concentration ahead of us, and the push of a vast void behind us. So, how much of this is actually solved? More than the name suggests. The Great Attractor is real. It is a genuine overdensity of galaxies. Our motion is now reasonably well described by that crowd, plus the larger shapely concentration behind it, plus the empty region pushing from the other side. This is not a case where science is standing there with empty hands. But what is still missing matters. The census behind the Zone of Avoidance is incomplete, because we are still forced to look through our own galaxy to take it. Exactly how much mass is hidden in that band, and exactly how much of our 600 kilometers a second each structure is responsible for, is still argued over in the literature. Different surveys give different weights to the pull and the push. And there is one more thing worth holding on to. Laniakea, our newly named home, is not gravitationally bound. Dark energy is expected to pull it apart over cosmic time. The basin we are falling into will not survive to see us arrive. We are falling toward it anyway, at 600 kilometers a second, without feeling a thing. If you had to bet, is the rest of the missing pull hidden behind the Zone of Avoidance? Or is it something we have not thought of yet? Tell me in the comments. Subscribe if you want to be here when the next survey finally maps what is sitting behind our own galaxy. This is Odd Signal. Keep listening for the strange ones.